Welcome to True Projects. In this video, we are going to explain about the project, which is an ensemble-based machine learning envisioned intrusion detection in Industry 5.0 driven healthcare applications. Before getting into the execution, first let us understand what is the project about. The healthcare industry is undergoing a major shift with the Industry 5.0. So it is undergoing with a shift called Industry 5.0, which is all about personalizing healthcare. So it is all about personalizing healthcare to meet the individual needs of patients. Instead of just providing standard treatments, this Industry 5.0 focuses on customizing healthcare services based on each patient's unique situation. For example, technologies like IoMT, that is Internet of Medical Things, connect medical devices to the internet, allowing doctors to monitor patients remotely, track their health in real time, and make adjustments to treatments as needed. Coming to artificial intelligence. So, artificial intelligence this plays a big role by helping to predict diseases early, offering personalized treatment plans, and even altering healthcare providers to potentially issues before they become critical. So, this approach improves patient care by making healthcare more proactive and tailored to the person. Rather than just treating general symptoms, applications like remote consultations, routine health monitoring, and disease prediction are all part of this shift. It's a huge step towards a more patient centric system where healthcare isn't just about reacting to illness, but about preventing it and managing health in the way that fits the specific needs of an individual. As healthcare system becomes more digitalized, they face significant issues related to security and privacy. So the increasing amount of sensitive data, so the increasing amount of sensitive medical data shared in the online markets, it targets for cyber attacks. So it targets for cyber attacks like malware injections, unauthorized data leaks, and also DOS attacks. These breaches can lead to identity theft, insurance fraud, and also damage reputations, eroding patient trust. While machine learning, it can help in detecting cyber threats, current systems they struggle to adapt to evolving attack patterns, resulting in the false positives or missed threats. So there is an urgent need for more effective and adaptive solutions to secure healthcare data in Industry 5.0 driven system. So to overcome all these solutions, so this project proposes an ensemble-based intrusion detection scheme for Industry 5.0 driven healthcare systems. It is designed to improve security by detecting and preventing cyber attacks. It works by combining different individual models that are support vector machine decision tree k nearest neighbor as SKD model into an ensemble model. So the idea is that by using a mix of different models, the system can identify threats more accurately and reduce false positives. This way, it becomes more better at spotting actual intrusions without triggering unnecessary alerts. To make the system work well, it is tested using well-known datasets that are nothing but NSL-KDD and KDD-Cup dataset, which includes a variety of network attack types such as denial of service and probing attacks. By integrating these different classifiers into one system, that is EIDS and also called as SKD, can use the strengths of each model to improve the detection and prevent cyber attacks from slipping through the cracks. This approach helps to create a more reliable and efficient intrusion detection system for healthcare sector, especially as it becomes more digitized and vulnerable to cyber threats. So this is about the proposed system. Moving on to the extension part, to further improve the accuracy of the project, we have incorporated stacking classifier, which is an ensemble model as the extension. So this approach combines multiple models to improve prediction accuracy and overall system performance. By leveraging the strengths of different models, the system was able to achieve the highest performance, making it even more reliable in detecting and preventing intrusions. And we also have developed front end using Flask framework. So we have developed front end using Flask framework. So this makes it easier for them to monitor security threats in the and also respond quickly. To ensure that only authorized person can access the system, we incorporated user authentication. This added layer of security helps keeping the sensitive healthcare data protected while providing healthcare professionals with the tools they need to manage potential threats effectively. Moving on, to implement this project, we have followed the steps of the flow of work. So let us understand them. First, what we have done is we have we have imported all the necessary libraries and packages like Pandas, NumPy, scikit-learn, and the others to handle data, build models, and creative visualizations. Coming to exploring the dataset. Here we examine NSL KDD dataset, which contains labeled data for network intrusion detection and contains different types of attacks. KDD cup. Similarly, the KDD cup dataset is also explored for its network data and labeled attack types, which will be used to train and test the model. The next step is data processing, where we remove duplicate data. Duplicates in the dataset are removed to avoid redundancy and also ensure model isn't biased. Then unnecessary or irrelevant columns are dropped from the dataset to streamline the data and focus on features that matter. The next step is data visualization. So data visualization here, visual tools like graphs and charts are used to better understand the data and observe trends or relationships among the features. Coming to label encoding. Here we convert numerical, that is categorical variables are encoded to numerical values to make them usable for machine learning models. Coming to feature extraction. Here in this step, the dataset is split into features as X and labels as Y, where features are the input data and labels are the output or target values. The next step is feature selection. Here we have used mutual info feature selection for selecting the relevant features and ignoring the irrelevant or redundant features. This makes it easier to train and reduce overfitting. Then we split the data into train and validation sets. So the data is divided into two sets, one for training the model, train set, and the other one for testing the model's performance, that is validation set. Coming to building the model. So here various machine learning models are set up like support vector machine, decision tree, KNN for detecting network intrusions based on the data. Then those built models are fed to the algorithm. So here the selected models are trained on the training data set, allowing them to learn patterns and make predictions. Then we compare, that means we evaluate all of them using accuracy, precision, recall, and FN score, and we compare them using graphs. And the front end of the project is built using Flask framework along with the registration. So here front end is created using Flask framework, allowing users to interact with the system. The registration and login system is implemented with the SQLite used to store the user credentials securely. In the front end, users they will be able to give the feature values for the intrusion prediction, and then that input will be pre-processed at the backend. It will be fed with the train model, and train model will be giving us the prediction. So this is how we have executed the project. Moving on to the algorithms used. These are the algorithms used in the project to predict the intrusion. So here we have used KNN, support vector machine, decision tree, and all of these three are combined in the SKD, that is the proposed model, that is an ensemble model. And also the extension model is implemented, that is a stacking classifier, combining bagging classifier with random forest, ET with the light GBM. As extension model has performed well, we have deployed it in the front end. Moving on to requirements of the project. To implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let us understand each of them, how will they be used in the project. Here in the KDD Cup dataset, we have KDD Cup folder, we have the dataset that is used in the project. Let's open this KDD Cup folder. Here we have KDD dataset. Let us open it. So this is the dataset that is used in the project to train so that we will be able to detect the cyber attacks. So these are the features. Just wait for a while. We have so many features. So here, these are the features that impact the cyber attack. Based on the features that we have, we will be having attack type. So here in the last column, we have labels at where we have the cyber attacks, different types of cyber attacks. This data set we will be using for training the models to detect the cyber attacks. Get back. Similarly, we will be having the NSL KDD data set also. Here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here in this models folder, we have the models files that contain the algorithm information which will be loaded into the project code during runtime of the project. So in this, we will be having .hy files, numpy files, and pickle files. And here we have two notebook files. So just give me a minute. Yeah, these are the two notebook files that are the Jupyter notebook files, which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So coming to this KDD Cup Jupyter source file here, we will be loading the KDD Cup dataset and will be training all the algorithms on this KDD Cup dataset. And coming to this NSL KDD, here in this Jupyter source file, we will be loading NSL KDD dataset and then we will be training all the algorithms on this NSL KDD dataset. And here in this sample file, we have the test cases that are used in the project to detect it in the front end. So here we have different types of test cases that we will be using in the front end to detect. And here we have KDD processed and NSL processed. So these were the initial data sets, right? After pre-processing, here we have the NSL and KDD datasets where we had so many features. So that will be from that we will be selecting important features and we will be removing null values. After all those things, here we have saved it as KDD and NSL processed. This is the signup.db file. This file is a database file which is used to store the user information. Now let's copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So here using the command cd followed by the space, paste the copied path. Now click on enter. This will change current directory to the code folder's path. Now compile the app.py file. So give the command python space app.py. Now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link and click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now we have to sign up. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. As we are using both the datasets that are NSL KDD and KDD Cup, let's do first prediction for the NSL KDD. Click on that. So these are the inputs that are need to be given for predicting the cyber attack. Let us understand them first. First, we have as the flag parameter. So this indicates the status of connection, that is success, failure, or specific condition. It helps in identifying unusual or suspicious connection patterns. Then we have SRC bytes, that are the number of bytes sent from the source, that is originating host, to the destination during the connection. Coming to DST bytes, these are the number of bytes sent from the destination back to the source during the connection. Logged in. This is the binary indicator, that is 1 for yes, 0 for no, specifying if the user successfully logged into the system. Coming to count, it is the number of connections made to the same host in a specific time window, useful to detect potential DDoS attacks. Coming to same SRV rate. It is the percentage of connections to the same SRV, that is same service, for example, HTTP, FTP, etc., as a current connection within a given window. Coming to different SRV rate, it is the percentage of connections to different services other than current one within a given time window. Next we have is destination host SRV count. It is the number of connections made to the same service on the destination host within a specific window. Coming to destination host, same SRV rate. It is the percentage of connections to the same service on the destination host within the window. Last parameter we have is destination host, different SRV rate. It is the percentage of connections to the different services on the destination host within the window. So this is all about the inputs that are need to be given. Let's enter them. For that, let's open the sample file in which we have test cases. So this is a file. Let's remove the filter first. Filter is applied here. So these are the test cases. Here in this sample file itself, we have test cases for NSL KDD in one sheet and another sheet we have for KDD cup dataset. Let's enter them. So here for NSL KDD, we have four types of attacks. Let's apply filter, let's select the zero class and check with that. And now let's enter the first case of zero class, and here flag value is 5. SRC bytes are 0, destination bytes are 0, logged in value is 0, 202 is the count, same SRV is 0.01, different SRV rate is 0.06, and destination host SRV value is 12. And here we have same host, destination host, same SRV, that is 0.05. Destination host different SRV is 0.07. Now click on predict. So based on the given input, we will be getting the prediction, and the given input will be pre-processed at the backend, and then train model will be giving us a prediction. So here we have the prediction that attack is detected and it is DDoS attack. Here attack has been detected. 0 refers to the DOS attack. So attack has been detected and it is DOS attack. Let us try giving one more input, one more class. Let's check with class 1. Click on OK. So yeah, let's enter the first case of class 1 where flag value is 9, SRC bytes are 1, destination bytes are 1, logged in value is 0, count is 7, different same SRV rate is 0.57, different SRV rate is 0.29, destination host SRV count is 4, destination host same SRV is 0.02, destination host different SRV is 0.98. Now click on predict. So here we got the prediction that there is no attack detected and it is normal. So 1 refers to no attack type. Let's try with the one more input, that is one more test case. Now let's try with the second class. Let's try with this third test case where flag value is 9, SRC bytes are 334, destination bytes are 0, logged in value is 1, count is 1, same SRV is 1, different SRV is 0, destination host SRV count is 23, destination host same SRV is 1, destination host different SRV is 0. Now click on predict. So this is the input. These are the inputs that we have given. And here we got the prediction as attack is detected and it is prop type. Let's try with the one more case of NSL KDD. Let's try with the first case of last case. Flag value is 9, 45 is the SRC bytes, destination bytes are 135, logged in value is 0, count is 75, same SRV is 1, different SRV is 0, destination host SRV count is 254, destination host same SRV rate is 1, and destination host different SRV is 0.01. Now click on predict. So here we got the prediction as attack is detected and it is U2R attack. It is the U2R attack. Now let's try with the other data set. Click on prediction, click on KDD cup, open KDD cup samples. Let's apply filter here also. Let's try with the 0 case first. Here flag value is 5, SRC is 0, destination is 0, logged in is 0, count is 135, same SRV rate is 0.08, different SRV is 0.05, destination host SRV count is 11, destination host same SRV is 0.04, and destination host different SRV is 0.05. Now click on predict. So here we got the prediction as attack is detected and it is DOS attack. Let's try with the one more test case. So here flag value is 9. Let's try with this one. Flag value is 9. 37 are the source bytes, 0 is the destination byte, logged in value is 0, count is 1, same SRV is 1, different SRV is 0, and destination host count is 1. Destination host same SRV is 0.25, different SRV is 0.75. Now click on predict. So here we got prediction that there is no attack detected and it is normal. Let's try with one more case. So let's try with this case. Give flag value as 9, 1 to 25 as source bytes, destination bytes are 2, 4, 4, 9. Logged in value is 1, count is 1, same SRV is 1. Different SRV is 0. 91 is the destination host SRV count. Different host same SRV is 0.36. Destination host different SRV is 0.02. Now click on predict. So here we got the prediction that attack is detected and it is probe attack. 2 refers to probe attack. Let's try with the last case of the last data set. Let's try with this case. So here flag value is 9, SRC bytes are 5924, destination bytes are 335, logged in value is 1, count is 1, same SRV rate is 1, different SRV is 0, destination host SRV count is 74, destination host same SRV is 0.508. Click on predict. So destination host different SRV rate is 0.08. Now click on predict. So here we got the prediction as attack is detected and it is due to our attack. Now let's check with the graphs. Click on about. So this is the NSL KDD sample outcome graph. So here in this graph on x-axis we have different attack types and on y-axis we have count. So this graph shows the distribution of each attack. So here if you observe normal cases are more than the other types of attacks. This is the correlation matrix graph. This shows the correlation between variables and here we have accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithm names. So these are the algorithms trained on NSL KDD dataset. And this is the precision score comparison graph. Here we have recall score and here we have FN score. Accuracy, precision, recall and FN score are the error metrics used to evaluate the classification models. So here we have used them. And this is the KDD curve dataset. Here on x-axis we have attack types and on y-axis we have count. This is the correlation matrix. Here we have accuracy, precision, recall and FN score graphs. Now click on sign out. In this pages, by giving required inputs to the system, it will predict which type of attack based on the trained algorithm. So this will help all the all the diagnostic centers and also the people who are storing their health data in the digital sectors. This is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.